Hi and greetings to all our audience. We are from Group 47 for ETP January 2020 semester. Name of our project is IOT Green House. Our motto is Human Increase Productions. Hi, my name is Desmond Goh Kai Hong. I am from Electrical and Electronic Engineering Department.
My name is Nazmi Afiq bin Jumaat. I am from Civil Department.
My name is Zuri. I am from Mechanical Engineering.
My name is Lazman Haris and I'm from EE Department.
Hi, my name is Nushaira Sabrina and I'm from Electrical and Electronics Department.
Hi, my name is Janai Sai and I'm from Chemical Engineering Department.
Hi, I'm Vishal Sen, Mechanical Engineering Department.
IOT Greenhouse System is a plant monitoring system that can be monitored through an applications. This project is initiated due to several problems which are lack of information such as the conditions of the soil and the irrigations of the plant. And the wilting of plant could happen if no constant observations on the temperature, humidity and moisture of the soil that may lead to low productions. Hence, we have these objectives which are to create an autonomous irrigation systems that retrieve and display the data of the sensors and control the irrigations and temperatures of the plant by various types of sensors.
As for literature review, there are three main aspects. The first one is smart farming. Smart farming involves the use of ICT, Information Communication Technology, and IoT, Internet of Things, to solve challenges via the usage of electronic monitoring of crops. Next is automatic watering system. The system helps to regulate irrigation precisely based on the farmer preference to supply water within the duration of time so the plant get the exact amount of water every day. Lastly, IoT, Internet of Things, helps on providing a system for monitoring the crop field with the help of sensor. Based on our survey, a majority of 72.5% of respondents is around 18 to 25 years old. A majority of 43.3% water their plant once in a several days. 75% of our respondents know that the temperature does affect the growth of their plant. 89.2% choose yes to have plant monitoring system that can be controlled by an app using our smartphone.
The first phase of our project, our team consulted the supervisor to voice out on ideas and proposals. Then we agreed to fabricate a greenhouse system, discuss with our supervisor how to improvise our project. Secondly, before we start our fabrication process, we finalized the concept project to the supervisor. Then, we purchased some items online and collected some recyclable items from the ETP store in Block 17. Lastly, for the third phase, we assigned into two teams, which are hardware and software, to start our fabrication process. Also, each of the team members do their own part for the report, poster, and logo.
For the methodology, the structure itself is made out of perspex. This is to mimic the characteristics of glass so it can absorb sunlight for the plant due to its transparency. As for the sensors, we are using two types of sensor, which is the DHT22 sensor and capacitive moisture sensor. The DHT22 sensor can monitor both humidity and temperature for the greenhouse. For the moisture sensor, it measures the resistance to indicate the amount of moisture in the soil. For actuators, we are using two DC stepper motors, one DC motor pump and one DC motor fan. The stepper motors are used to open and close the roof of the greenhouse. The water pump would run to irrigate the plant, and lastly, the fan would help in air circulation in the greenhouse.
Continuation from the methodology part, Raspberry Pi 3 act as our controller and the graphical user interface are using the Node-RED software. Basically, all the system configuration are using the Python commands and Node-RED flows. And from the flow side, all the actuators are triggered by different sensor measurement indicating their own functionalities, as being mentioned by Lazman just now. And for more elaboration on the whole process, we will make again during the demonstration part. So for now, we'll let Janet to take the floor. Please welcome.
Next, for design discussion part, I will explain further. The main purpose of the ventilation system in the greenhouse is to prevent the air temperature inside the greenhouse from rising too high from the outside temperature. We also have circulation fans to keep the air moving throughout the greenhouse and to make sure it's distributed to all the plant. Once the DHT22 sends the temperature less than 30 Celsius, the roof will close on both sides. Otherwise, the roof will be open to let the fresh air and to release the hot air. Next, the HT22 sensor also senses the change in humidity. If the humidity is less than 65%, the fans will be turned on to increase the humidity level. Otherwise, it will be turned off to achieve the optimum level. Lastly, for soil moisture, the moisture sensor will sense if it's less than 300, so it will consider dry. Water pump will be triggered to irrigate the plants for 10 seconds. For business and economic considerations part, our project will be beneficial to the farmers as it can ease their job and increase the production. To add, it is also affordable as total cost of our project is less than 500 ringgit.
So I'll be touching on the conclusions and also recommendations for this prototype. So as of the recommendation, I'll just start it first because there's only one of it, and that too under the electrical component. So the recommendation is to add on one switching power supply so that we can get different voltage values instead of using two alternating power supply, and this can further enhance the efficiency of the prototype. Now moving to conclude all of this. So in a nutshell, IOT Greenhouse should be implemented or should be introduced to all who are under the agricultural and also farming industry. Initially, this may be rebutted and may not be supported by the traditional farmers, but to know the fact that they have everything at their fingertips to control the water to their plantations, to be able to see the humidity, the moisture, and also the temperature. This is actually a great plus point to these who are under this industry. So I believe this should be introduced and also be implemented in the industry. With that being said, the problem statement has also been addressed here. Thank you.
For the demonstration part, this is our hardware and its properties and parts. Basically, it's being supplied by two different power supply, and the overall circuit look like this. As you can see, these are the real circuit and interface that display all the features mentioned just now, and I've adjusted it to be used for the demo, which I stay on the side. Let's start by focusing the switching and with the soil condition. Right now it's below the 300, so it considered dry. That's why the water pump is being triggered to irrigate the plant. Next, for the humidity, okay, right now the fan is being turned on as previously the humidity value is below than 75. And then next, later on for the temperature controlling, I will adjust it using the decimal number. If it's more than 32.1 Celsius, it will be open just like now, or else, yes, it will be closed back.
The interface is also accessible to any kind of devices as long as it's been connected to the same router or Wi-Fi. As the example that could be seen here, the real-time data are monitored by both notebook and smartphone.
For the justification, from the graph we could see the constant, the optimum value from all the sensors after the system is being implemented. And as the summary, here is the project flowchart. And that's all for the demonstration. Let's have a look at our poster.